Y'all usually do, though. Y'all good class. All right, so combining like terms. Now remember, we've talked about the fact that that arithmetic and algebra are different. What is the only one thing that makes them different? The introduction of what are they called? Variables. Excellent. Those letters. And a variable simply stands for some unknown number. Something you don't know the name, know the value of. So you just give it a placeholder, right? And you can use whatever you want to. If you're talking about pizzas, then you might use the letter P, right? Some of them are traditionally left for certain things. M usually means gradient. Come on, guys. A gradient, right? So some letters are reserved for certain uses, but otherwise use something that makes sense to you. The two most common ones are X and Y, simply because they're just easy. Right? Most words don't start with X, so there's not a whole lot of things you could confuse it with, right? So we're going to talk a little bit about combining like terms. So the first thing I want to do is remind you of the pieces of a term. We talked about this last time we were here. How many parts are there for every algebraic term? 4 parts. Okay. The first part is its sign. Good. That it's either that plus or minus. Second part is called the coefficient. Now, this coefficient is simply another word for a multiplier, right? But in a term, the multiplier is always the number. So does that mean coefficient means number? Nope. Coefficient means multiplier, but in a term, the multiplier is always a number. Make sense? Okay. Third part? Base. And the base of a term is always its what? Variable. Now, the base of everything doesn't mean variable, but the base of a term means variable. Okay? And then finally, on every base, whether you see it or not, there is an exponent. Okay? These two are usually taken together, and they literally tell you what? How many of something you have. Okay? These two are taken together, and they literally what? Name it. Name the term. You're halfway through algebra if you can understand that. Yeah. Because if you know how to put things together and if you know what things mean, then you can arrange them and rearrange them and you can work with them. Okay? But if you don't know this, you're halfway on your way to trade school. Because you're not going to ever get algebra. That's how critical it is to understand these pieces.
What's trade school?
All of your hopes and dreams? Yeah. Oh, baloney. Okay?
What's trade school?
I just want...
What if my dream is basically when you learn like physical traits like plumbing.
Yeah. Which, hey, there's nothing wrong with it. Because I'm telling you, there have been times I have worshipped some plumbers. If you need a plumber badly, you're like, they are the greatest person on the planet no matter what. Okay, so moving on. Guys, okay, so today what we're going to do is we're going to talk about combining like terms. Now, I've got some talking to do about this. You know me. The first thing I want to do is I want to talk about this word combining. Okay? We say combining not add or subtract. Because if you'll remember, the first part of its term is its what? Sign. So, when you're talking about combining these things, we have to consider the signs. And do you remember the rules for combining with signs? There are 2 of them. if the signs are the same. What do I mean by the same? Either both numbers you're combining are positive or both numbers you're combining are what? Negative. Doesn't matter which ones. It's just what matters is that they are the what? The same. Then what you're going to do is you will keep the sign and then you will add the numbers. Remember that? So, 2 negatives make a positive? That's not a rule. If you're combining 2 negatives, then your answer is going to stay negative. Right? Now, again, I don't know how much work you've done in signs in the past, so that's why I'm reviewing it here, but I'll always make sure you know those. Yes?
When does if you have 2 negatives make it positive?
Well, that's never really a rule, because you got to put an operation symbol in there. Now, a negative times another negative becomes a what?
Positive.
But do you see that you have to say the operation. So it's never a rule without its operation. A negative combined with another negative stays a negative. A negative times another negative becomes a positive. So do you see the difference? You've got to have the operation in there so that you know which rule you're using. Okay? All right. Now, the other rule for combining says that if the signs are different, what does it mean if the signs are different? One of them is positive and the other is negative. Or the other way around. The first one could be negative and the second one could be what? Positive. Okay? Now here, we have to think about what's happening. Okay? Because we have to look at the number value and see which number is bigger. Okay? All right? Now, this is not always true, but I'm just going to use it as an example. If you have a small child and a parent, parent's bigger, right? Who usually gets their way? Yeah. In your home, I have no doubt it's the child. But the parent, right, sets the rules. Yeah? So the same is true of numbers. If one number is bigger than the other, it pretty much gets to tell the smaller number what to do.
Oh, sad.
Okay? All right. So here's what happens. We're going to still keep one of the signs, but we'll keep the sign of the larger number. Now, I'm not talking on a number line. We're talking about something called absolute value. Have you heard that term before? Absolute value means the number without the sign. So what is the absolute value of a -5? It's just plain old 5. Okay? Absolute value literally is a distance measurement. The distance from 0. Okay? So it's just a distance. And have you ever seen negative numbers on your ruler? No. Okay? Yes?
So if it was a negative number that was 5 and there was a positive number that was 3, the negative number would win?
The negative number wins.
Wait,
Exactly.
what's it
Okay? Absolute value.
Absolute.
I'll write it down in just a second. I'll put it in the notes. Okay? Now, and since the signs are different, isn't there an operation that even has the name difference? Which operation can also be called difference? Subtraction, right? That's where difference comes from, is subtraction. So what you're going to do is subtract the numbers. If the signs are different, you're going to take the difference. So that means you're going to be subtracting. But you have to first determine the sign. So we're going to look at some examples together just to remind you of what's going on. And again, the way I write the rules might be different than the way you've learned them. But so I want to make sure that we're hitting the right notes here, right? Okay. You bet. So, absolute value, and you're not going to be responsible for this right now, but you can be. Absolute value is represented by those two upright bars, right? And the absolute value simply means the distance from 0. And as a distance, it can never be negative. Because there is no such thing as a negative distance. If you walk 10 feet that way and you walk 10 feet this way, you've walked 20 feet. You haven't walked 0 feet, right? You can't erase a distance. You still just add it. It doesn't matter. The direction in distance doesn't matter, does it? It's still positive. You can't move back. Even if you move backwards, you're still moving, right? Measured in a positive number. So, if you see absolute value of 4, the absolute value of 4 is just 4. The absolute value of negative 4 is also 4. Because if you look at those numbers on a number line, 1, 2, 3, 4, 1, 2, 3, 4. Sorry, my number line is bad. Okay. If that's 0, how far from 0 is this 4? How many units? 1, 2, 3, 4. 4 units, right? How far from 0 is this negative 4? 1, 2, 3, 4. 4 units.
Oh, what is the negative one?
Nope. Doesn't matter. It's just how many units. Right? Okay. Don't worry about that. We're not adding them together. So there we go. So that's absolute value. It simply means a distance, and distance can never be what sign? Negative. Okay? So, all right, so absolute value. And again, that's not part of the lesson. That was just a question, and I'm just happy to answer it. Okay, so let's look at some examples, guys. And what I want you to do is, I want you to think it through and try to come up with the answer, and then we'll do it together. All right? So let's say we have negative 4 plus 9. And I'm going to walk you through a series of steps that I want you to ask yourself. Okay? Are we there? Okay. Some of you not. Okay. All right. Let's see. All right, well, let's walk through the steps. The first question you need to ask yourself, no matter what problem you're ever doing, is what operation are you dealing with? Because remember, in mathematics, you're forced to follow the order of operations. Okay? And if you look, there are no brackets. Sorry, I still call them parentheses. No brackets. Or do you see any exponents? Nope. Is there any multiplication to be done?
No.
Division?
No.
Well, that means then it has to be addition or what?
Subtraction.
But in algebra, we call addition and subtraction combining. All right? So do you see again in algebra, and that's what happens, is the rules change, and that's where people start to lose it. Because they don't want anything. It's not different. It's just a different way of thinking of things, right? Okay? Combining means you can be doing either addition or subtraction depending on what operation symbols you have. So we're going to be combining. Well, if I'm going to be combining, the first thing I need to do is determine the sign. Sign errors are the biggest mistake that students make in algebra. Because they don't take the time to stop. They're too concentrated on the numbers, and then they forget the signs. Even if you know the sign rules really well, and you just forget to write it because you don't put a priority on it. Okay? Does that happen to you sometimes? You do something over and over, and it's like, gosh darn it, I have forgotten my whatever again. Right? Happens all the time. Now, so you're always going to determine the sign first. So what is the sign of the 4? It's a negative, right? What is the sign of the 9? A positive, right? Well, which one is bigger? Well, 9 is bigger than 4, right?
Yeah.
Okay? Isn't it? Well, if 9 is bigger than 4, then the 9 wins. Okay? So our answer is going to be a positive. Right? So what if the 9 had been negative? Then the answer would have been negative. Right? And then finally, we're just going to combine the numbers. Okay? Which means either add or subtract them depending on the rule. Are the signs, are they different? Or the same? They're different, so that means we're going to subtract them. So just take 9 minus 4, which is, so your completed answer is positive 5. Now, do I need to write the plus in front? No. I would just write 5. But because we're now algebra students, when you say it, what are you going to say? Positive 5. Right? The more you say something, the more you get it into your head that the way it should be, right? Okay? So positive 5. It's like me trying to learn your names.
I don't really understand how you got 5.
Well, because remember, one of them's negative and the other is positive. So that means we're taking the difference, right?
Yeah.
And so the difference just means subtract. So what is 9 minus 4?
5.
There you go. And that's how we got it, right? You're taking the difference. If the signs are different, you're taking the difference. Yes?
In a test, would you have to write positive 5 or just 5?
Absolutely not. This is what I would expect you to write. But if I ask you a question, I would expect you to say, there you go. All right? Now, if you wrote the plus, I would never count it wrong. Some teachers might. So you need to know what are their standards, right? Because it's really not in simplified form until you just write it like this. All right, let's do another one. Say we have negative 12 plus 3. Now this looks like I'm adding, doesn't it? But you can't just assume addition. Instead, we have to pay attention to the, what are they called? Signs. There, yeah. So what's the sign of the 12?
Negative.
What's the sign of the 3?
Positive.
Are the signs the same or different?
Different.
Different. Which means I need to keep the sign of the larger. What's larger, 12 or 3?
12.
So that means my answer is going to be what sign?
Negative.
And then all I need to do is go back to the numbers and what?
Subtract it.
So what is 12 minus 3?
9.
9. So my completed answer is
Negative 9.
boom. Could it be any easier? Yeah. But what happens to stuff that's easy though? No. We don't practice it because we think we know everything. Now I know as year 8s, y'all don't think you know everything. Just way more than I do, right? You all know more than I do. I know that. But, okay. Trust me, if it's something that seems easy, it's something also that you're not going to work on. Okay, now, we haven't put any variables in, so we need to talk about putting variables in. We need to talk about what like terms are, and again, this is review, so that's why I'm spending so much time with this sign. Terms are only like terms if they have exactly. Now, if I'm going to write down the word exactly, and underline it. What does that tell you? It's important. Thank you. Exactly the same base. Good job. And exponent. Not just one, but both of them have to be the same. And if they are to like terms, then to combine, okay, you're going to keep the base and exponent. Doesn't change. If I have 3 cars and I add 7 more cars, then I have 10 cars, right? What they are doesn't change just because you have more or less of them, do they? Okay? So you keep the base and exponent, and you combine the coefficients. And the coefficient of a term simply means the number parts. And in order to combine them, you pay attention to the sign rules. And that's why we say combine instead of add or subtract. Right? Do you see it building? But you need to build it in small pieces. So let's look. Say we have negative 4x plus 3x. First of all, these are algebraic terms. Can anybody tell me why I call them algebraic terms? They have variables in it. The only thing that makes something algebra is the letters, right? So they're algebraic terms. And we want to see if we can do what to these things? What's the word with the starts with the C? Combine them. Good. But in order to combine them, they have to be like terms. Are they like terms? Yes. All right. Do you want to see how I got through graduate school without being able to add, subtract, multiply, and divide? I'm terrible at math. I've told you that before.
What?
Let me show you. I'm terrible at
Why
math.
are you teaching us?
Well, because I've learned how to do it because I was terrible at it. I hated that. So I've learned how to teach it because I had to teach myself.
Okay, so everyone who hates math, then you become a math teacher.
Exactly. Perfect. I love it. So we are going to combine. Now look at what I'm doing. So what I'm doing is I just write it off to the side, everything that I need to do. And this is the way I went all the way through my master's degree in mathematics.
So you're working it out.
I'm working it out piece by piece. Yeah. So the first thing I need to do is see, are they like terms?
Yes.
And in this case, they're both what kind of terms? X terms. Remember the name as the variable? So they're both X terms. So they are like terms. So yes. All right. So I'm going to keep the base. So what is the base? X. Okay. And I'm going to combine the what? Coefficients. Okay. But in order to do that, I need to know the signs. Are the signs the same or different? Different, right? So that means keep the sign of the large, of which one?
The big one, which is the negative.
Which is the negative 4. Negative 4 is bigger. 4 is bigger than 3. Negative 4 is actually very much smaller than 3, right? But just look at the number, the absolute value of the number. So that means my answer is going to be a negative. And then, what am I going to do to the numbers? Subtract the numbers. What's 4 minus 3?
1.
So my completed answer is negative 1x. But I can simplify that a little bit. Now, this is a perfectly good answer. But what can I write instead?
You can write negative x.
There you go. The 1 is assumed to be there if you write it or not. Right? Remember the pen? 1 pen or just pen? Pen. We assume 1. Right? So, there's your answer. Okay? What if I have, and did you see the way I wrote down everything? If things are complicated, while you're learning them, write out the process. And then once you write it out, what's going to happen is it's going to stick in your head. Now, do you have to always write it out in such detail? Nope. Once you start learning things, you can write just abbreviations even. Or just the steps that you know that you have difficulty with. Yes?
Would this be the same if it was like 3 or 4 or 5 numbers?
Terms. Yep, that's what we're going to look at. Yes, the process never changes. So let's say we have 6y minus 3y plus 2x plus 3x minus 6x squared. Let's do it. Right? First of all, do you have any brackets?
No.
Oh, stop that. No, there's nothing. It's bigger, but it's the same rule. Do we have any brackets?
No.
Do we have any multiplication? No. Do we have any division to do?
No.
Then that must mean we have some combining to do, right?
Yes.
In order to combine these, because they're algebraic terms, they must be things that are called what? Like terms. There you go, guys. Right, like terms. So what kind of term is the first one? A y term. So just look along and see, do you have any more y terms? Yes. Here's another one. It's negative 3y's, right? Are any of those other terms y terms? No. So do you see, when I have a long string of them, what I tend to do is circle the ones I'm going to use them, and then move on. So those two are both y terms, so they can be combined. In order to combine them, right, remember it's going to stay y. What's the sign of the 6? Positive. What's the sign of the 3?
Negative.
Well, 6 is bigger than 3, so we're going to keep the sign of the bigger one, so the answer is going to be what sign? Positive. And since the signs are different, are we going to add them or subtract them? Subtract. Oh, be careful. The signs are different, so we take the difference, right? It's a positive 6 and a negative 3.
Oh.
Okay? It's all right. It's okay. So 6 minus 3 is just going to be what? 3. So positive 3y is our first term. Now, we can still clean that up, but we're not done, so we can clean it up at the end, right? Okay. Now, we're done with the y terms. What kind of term is this? Okay. Do I have any more x terms? How many more x terms do I have? 1. Because this is not an x term. This is an x to the second power of 2, or an x squared term. So these two are like terms because they're both x terms. But an x to the second is a new kind of term. Right? So these can be combined. Positive and a positive are going to stay what? And 2 plus 3, their signs are the same, so I'm going to add them this time. 2 plus 3 is 5 what? X's. Those are done. Okay. And then, what about this one? Are there any more x squared terms?
No.
So I just get to throw it away, right? No. What happens? Just bring it down, and it doesn't get combined with anything. It just stays the same. And there's your answer. Now, I could clean it up one bit. There's one thing on there that you could clean up. What's that?
The plus.
The plus in front of the 3y is not necessary. Now, would I count it wrong if you wrote the plus in front of the 3? No, I think you're being good. You're paying attention, and you're doing what's right. Would some other teachers, though?
Yes.
Don't know. Right? So you need to ask that question. Would you be counting it wrong if I include the sign? Now, later, you're going to get so used to it, you're not going to want to, probably. Because what's the one rule about everybody? We don't want to do what we don't have to. Okay? So you might not. All right? Now, be careful with this one. What's special about this one? Are they like terms?
Yes.
What else about them?
They have the same coefficient.
Same coefficient. So, and the signs are different. It's a positive and negative. So if you take 3 minus 3, you get what?
0.
So does that mean I get 0x? No. If you have 0 x's, then you have just plain old what? 0. If you have no x's, if you have no apples, why say apple? Look at this. In my lunch today, I have no ham, I have no turkey, I have no bread, I have no apples. Why would you say stuff you don't have? Just say the stuff that does still exist, right? Okay? All right. How about this one? Like terms or not?
Yes.
They are like terms. There's just something wrong with one of them. I have no problem with 3AB, but what is my problem with 6BA? Alphabetical order is the convention, and that's one of the reasons why it's a convention. Because now, are they like terms? Yes. So 3 of them plus 6 of them makes 9 ABs. Okay?
9 ABs.
9 babies. No, 9 ABs. Okay. All right. So make sure that you pay close attention because the terms might be rearranged. Okay? How's it looking?
Fantastic.
Not bad? Okay. Well, you're going to have an assignment, and literally, I've given you this assignment before in the past. So you do not have to do this assignment, but if you want the practice, then you should, right? You know where you are, right? I'm not going to make you. Clearly, I can't make you do homework anyway. But it's there for you.